Hi, everyone. This was supposed to be a face-to-face panel discussion in Essex, and it had to be canceled because of the coronavirus and limitations on how many people could be in a room. So we're doing it this way. Hope that we can get this information across to you. So the name of the presentation is Too Hot to Stay, and it relates to the Threads CBC book. And we're going to start off with Dr. Norfolk.
All right, so I am going to do a short little introduction about some climate change myths that you may have heard and some facts behind the myths. All right, so this was supposed to be, as soon to be Dr. Cardona said, face-to-face. So I have this as a question and answer format. So shout out the answers in your head. Weather and climate are the same thing, true or false? False, as taken from NASA. The difference between weather and climate is a measure of time. Weather is what conditions of the atmosphere are over a short period of time, and climate is how the atmosphere behaves over a relatively long period of time. So weather is today it is raining. Climate is the mid-Atlantic has moderate temperatures. Okay, another true or false. The sun is getting hotter. False. The sun is not actually getting hotter, although the sun does go through cyclical periods of solar activity. So as shown in this illustration, the yellow represents solar irradiance from 1880 to relatively the present day. And you can see that although it does have some ups and downs, it has remained relatively stable through the ups and downs, whereas the red indicates the temperature from 1880 to 2020. And as you can see, that has gone up steadily independent of anything the sun is currently doing. All right, this one's a tricky one. How much has global temperature risen in the last 100 years? The correct answer is D, 1.6 degrees Celsius. So once again, we have more data from NASA showing that from 1880 to 2016, the temperature has steadily increased to about 1.6 degrees Celsius above the average temperature. All right, another thing we often hear, well, higher temperatures aren't that much of a concern. 1.6 degrees isn't that much. Is that true or false? False. We have some evidence that 13 of the 15 warmest years in the past 150 years have occurred since 2000. So we've had 13 of the warmest years on record in the last 20 years over the course of 150 years. That's saying something is probably going on. The Arctic is warming the fastest. It's warmed about 4 degrees Celsius or 7 degrees Fahrenheit over the past 50 years. And this is causing permafrost to melt in Alaska and Canada, and houses, pipelines, and trees are actually being toppled. And we can see in these illustrations here, this is what happens to roads when they destabilize due to increased water and increased flooding. And you can see what happens to houses too. They're not exactly straight. All right, the climate is cyclical and the cause of the warming is not caused by humans. Think about that statement. False. How do we know this? Well, we know this because of modeling. So we can model what the climate change would look like if humans weren't around and we only had natural forces versus what the human effects are, and then look at what we observe. And you can see that the black line is what we observe, and it pretty much goes right in line with human effects. With natural forces only, and the fact that the climate is cyclical, we would not see this much increased climate change, increased warming. All right, which of the following are considered greenhouse gases? Carbon dioxide, methane, nitrous oxide, CFCs, or E, all of the above? The answer is all of the above are considered greenhouse gases. So what are greenhouse gases? Greenhouse gases trap heat in the atmosphere, such as carbon dioxide and methane. So the heat from the sun comes in, and a lot of it should be bounced back into space, but because of all the greenhouse gases in the atmosphere, a lot of that heat gets trapped and can't get back out into space. So most of the greenhouse gases in our atmosphere are carbon dioxide, followed by methane, nitrous oxide, and fluorinated gases. Methane is actually a worse greenhouse gas than carbon dioxide in that it holds more heat, but there is more carbon dioxide in the atmosphere. And where do these gases come from? Transportation, electricity, industry, agriculture, because we have cows, and a little bit from commercial and residential. So CO2 has always been in the atmosphere. Why is there a problem now? It's a good question. So it has always been in the atmosphere, and it's maintained at certain levels in the atmosphere because we have sinks. So the oceans absorb excess CO2 in the atmosphere, and so do land plants. They absorb CO2 to make carbohydrates, which we then eat. But the levels of CO2 currently are rising faster than the sinks can absorb them, and the ocean has absorbed so much CO2 that that's causing changes in the ocean, which I'll talk about in another slide. So yes, we've always had carbon dioxide in the atmosphere, but now it's getting so high that we don't have any sinks that can absorb it anymore, at least not healthily. All right, the world's oceans are becoming more basic or acidic. We are acidifying the oceans with the carbon dioxide. So if we look at this illustration, the one on the left represents the late 1800s. So the pH of the ocean was a little above 8. So carbon dioxide still got absorbed by the oceans at relatively normal amounts, which produced carbonic acid and some free hydrogen ions, which could be absorbed by bicarbonate. And we also had abundant healthy corals, mollusks, and other marine calcifiers. So all of this healthy ocean. Fast forward to 2100, this is projected that the pH of the ocean will drop below 8 because it's absorbing way more carbon dioxide than before, which yields more carbonic acid and more free hydrogen ions with fewer carbonate ions, and then our marine calcifiers are getting smaller and there are fewer of them, which of course affects all parts of the food chain as well. All right, sea ice is decreasing, true or false? This is true. Canada's decreasing sea ice is shown in the graph on the left. Summer sea ice is decreasing by nearly 7% a decade. That's a pretty steep descent there in that line. So this is average sea ice area in millions of kilometers squared. So we went from just under 1.5 million kilometers to just under 1 million kilometers. So we lost about 500,000 kilometers of sea ice. That's a lot of water. And then if you look at the graph on the right, average monthly Arctic sea ice, this is millions of square kilometers, and you can see from 1980 to 2016, we have seen a sharp decline in Arctic sea ice. All right, sea level rise is caused by melting land ice. True or false? True. Global warming is the primary cause of sea level rise because ice is melting. Shrinking glaciers and ice sheets are adding water to the world's oceans. So when the land ice melts, it goes into the sea, and yeah, that's going to cause sea level rise. So the oceans are warming, which means the seawater is expanding as temperature rises, because as things get hotter, they tend to expand. So that's also leading to an increase in sea level. So contributions to global sea level rise, melting land ice, warmer oceans, and other causes. So sea level rise is a long-term concern. We're okay for now. We can worry about that later. I mean, it's not like everything's going to flood tomorrow, right? True or false? False. Mean sea level rise and days of nuisance flooding. Nuisance flooding is the kind of flooding that happens when it's not actually raining, that it's another name is sunny day flooding. And that's been happening a lot more frequently. So sea level rise has increased the frequency of nuisance flooding in Annapolis, which is right in our own backyard. So it's 1 foot above mean high water level. And you can see over the last 65 years, that's been happening a lot. So it's not something that can be thought of as a distant problem. It's happening now. You've probably all seen pictures of the Inner Harbor and Fells Point underwater, and it's happening more and more often.
So as Dr. Cardona said at the beginning of this presentation was partially driven by the community book Threads, which is all about refugees. We know that climate change is going to have an impact on human populations in many ways, and it is likely to cause a refugee crisis in many ways. But for the sake of this presentation, we have chosen to focus on a specific issue caused by climate change, which is sea level rise. Sea level rise is projected to displace whole communities over the next few hundred years, well, recently and into the next few hundred years. So this graph is showing modern eustatic sea level rise. Eustatic means global. When we're talking about sea level rise, we have to look at both global and local data. So we'll start with the global data. And I want everyone to take a moment and look at this graph and look at the trend line. So the squiggly lines are representing kind of the annual data. And then the black and green lines represent the trend lines. Hopefully you're all familiar with trend lines from your science classes. But look at those trend lines. Are they the same? I'm going to have Professor Cardona go ahead and click a few buttons here. Keep going. One more, and one more. As we look at this sea level rise curve, we see that the rate of sea level rise is increasing dramatically. From 1900 to 1930, we were only gaining about less than a millimeter a year. But speed up to 2010 to 2015, we see a rise of 4.4 millimeters a year, which is a drastic increase. And as Dr. Nortel said, this is primarily driven by melting land ice as well as thermal expansion of water. So let's go ahead to the next slide. All right, so I always like to have little cartoons in my presentation. If you can't read this, it says, good news, at the current rate of global warming, we should be able to just swim over there and eat him in under 5 years. And as Dr. Nortel said as she wrapped up, sea level rise is a modern day problem. It is an issue here and now. And so we're going to explore what this means for local communities. So just reiterating this one more time, there are two main contributions to sea level rise. One is melting glaciers, so that's melting land ice, and the other is thermal expansion. So as Dr. Nortel said, when you heat things up, they tend to expand. This is why you should never put a closed container in your microwave and heat it up, because the water in that closed container, if there's the water in there, will expand until it bursts. My cousins attempted this with a squash many years ago. They put a squash in the microwave, and of course squash, they didn't poke any holes in it. And of course squash has a lot of moisture in it. And so as that squash heated up, the water inside that squash expanded until it blew the microwave apart. So obviously not quite so drastic in the oceans, but the oceans are experiencing thermal expansion, which is a contributor to sea level rise. So let's focus in a little bit. When I was working on my dissertation, and my dissertation was on sea level rise, one of the things I commonly heard is, oh, I'm not experiencing sea level rise where I live. And the reality is that statement may be partially true, because the graph we were just looking at a few slides back is global sea level rise, and globally sea level is rising. But we also have to look at the local picture, right? Global picture and local picture. If we look at this graph, we see sea level trends for different locations. And we see that around the United States, the rate of sea level rise is not the same everywhere. right? So we see that Baltimore and New York City, New York, are both experiencing a rise, okay? But then we look at Galveston, Texas, and the trend for Galveston, Texas is much more dramatic. And then actually we look at Alaska. You see Alaska, the bottom one there? Alaska is actually experiencing sea level fall. And the reason for this is, like most things, it's more complicated than what we might initially think. And so it really is important to understand the consequences of climate change. We need to understand the complexity of the issue and why places like Texas and Louisiana are losing acres of coastline every year, and places like Alaska, not as big a deal with sea level rise. Now, as we saw in those pictures from Alaska, from Dr. Nortel, Alaska has its own problems. There's plenty of problems besides sea level rise. But it's really important that we understand that sea level rise is a complex issue and that not every location will experience the problem at the same rate. And so why is this? Why is Texas experiencing dramatic sea level rise and Baltimore only moderate? Now, moderate's still bad, okay? But why do we experience these differences? Well, one of the big reasons is something we call subsidence. Subsidence means sinking, right? And so when you extract resources from the ground, you leave a void in the ground, and the land will sink to fill that void. When you think of Texas, what resource do you think of? Hopefully you're all thinking oil. And oil extraction in Texas has actually caused sea level rise to be worse in Texas, because when they extract oil, right, they leave a void in the ground and the ground sinks. And when the ground sinks and the water comes up, you have a double whammy. Now here in Maryland, we're experiencing less subsidence. We're definitely experiencing some, but we're experiencing less. And as a result, our sea level rise is not quite as dramatic. Okay? And the same can be said for water extraction. So areas in which they're extracting water rapidly, they're going to have more land sinking than areas that are not extracting water as rapidly. Next slide. And so what does this look like? So this is a really nice graphic from New Orleans, which is of course experiencing really bad sea level rise. And on the left-hand side of the picture, we see what we can call current conditions. And then we see what it would look like in 100 years with just sea level rise. And then we see the problem in 100 years with sea level rise and subsidence. And you see how the subsidence makes the problem worse. Okay, so Louisiana, Texas, many of the states down there in the Gulf are experiencing a double whammy. Globally, the water is rising and their land is sinking. And this is a particular issue in Louisiana, where they have these nice muddy shorelines, and those nice muddy shorelines compact very easily. Okay, and we have less of an issue with this in Baltimore. Once again, the population in Baltimore is less of an issue. So this graphic kind of shows us how it's double whammy. Water is definitely rising, but then the land is also sinking, and it creates an even bigger issue. So, can you go back one slide? I apologize. So why is Alaska not experiencing sea level rise? And the answer is there's another type of subsidence. So far I've been focusing on the shallow subsidence, but there's also a larger subsidence. And this larger global subsidence happens when we see these ice melt. And for the sake of time and at this level, I'm not going to go into too much depth on that, okay? But what we see is called isostatic adjustment. And so about 20,000 years ago, there was a glacier that came down to about New York City, okay? And as that glacier melted, the northern half of North America started rising up, and the southern half of North America started sinking down in order to reach an equilibrium again. And what's happening is that Alaska, because of adjustments as the glacier melted, right? So because of adjustments as that glacier melted, Alaska is actually experiencing a little bit of rising land. So on a big continental scale, Alaska is actually rising up just a little bit. And in many parts of Alaska, that actually means that it's rising slightly faster than global sea level rise, which is why places like Alaska aren't having as many issues. Okay? Once again, that's the goal of this presentation. Meaning that we need to understand the geology of specific locations if we are to truly understand sea level rise. All right, now we can move on. So why does this all matter? Well, it matters because sea level rise equals shoreline loss. And I know this picture is a little blurry, but as you look at this, we can see that as these are areas around our country that are experiencing shoreline loss, because as the water comes inland, that's less shoreline that we have. And you can see, as I was saying, that areas around the Gulf have a lot of red. Okay, so if you look at the map, those are areas in which they're experiencing severe coastal erosion. And in fact, Louisiana is losing whole football fields of shoreline every year. I think it was a year or two back, they had to redraw the Louisiana coastline because so much of it was gone. Okay, and you can see that we see some variation around our country. And that variation around the country has to do with variation in the geology. Okay. But even when you look up near where we live, up here in Baltimore, we do see plenty of red and orange, showing that we are experiencing pretty severe shoreline loss up here in Baltimore as well. Or I should say Maryland, since Baltimore is not specifically on the ocean. Go ahead. And so I like this graphic. I found this graphic a few years ago. And this is showing the extent, this is kind of helping us visualize the extent of the problem. It says, when Cape Hatteras Lighthouse was built in 1870, it stood a safe 1,500 feet from the ocean. After a century of shoreline erosion, the ocean was a mere 120 feet away. In 1999, the lighthouse had to be moved inland. Okay? And this lighthouse is just one small example of how much infrastructure we have along the coastline. So yeah, we can move one lighthouse inland, but can we move whole cities? Right? We live very close to our coastlines, and yet those coastlines are getting closer and closer to us. And one of the big questions we have, and we'll explore this later, is what are we going to do? How are we going to handle this problem? How are we going to protect the people who live near these coastlines? Because whole cities can't be moved inland as effectively as a lighthouse. So I wanted to zoom in and look specifically here at Baltimore. So this is showing us the Baltimore region. It's showing sea level rise by location, and I zoomed in specifically to the Baltimore location, and we're seeing here in Baltimore, we're losing about, we're seeing about 3.2 millimeters a year of sea level rise. This is an issue right here in Baltimore and around the whole region. And just showing a satellite imagery of just how much of our coastline is exposed, right? How close we live to the water. Oh. And there we are. So what does this mean for the future? Well, we don't know for sure. A lot of what the future will look like depends on choices we make today. We know that sea level rise is not going to stop anytime soon, but how fast it gets really will depend on how fast we continue to warm. But by the end of the century, we do expect to see about a whole meter of sea level rise. And in fact, so that's the red line. The red line is the projection, and then the blue line is projection best case scenario. In fact, most scientists, most scientific papers I have read recently completely discount the best case scenario. They don't think the best case scenario is likely. They suspect that right now we are most likely going to see at least a meter of sea level rise by the end of the century, if not more. And if our rate of warming speeds up any more, which it is likely to do, we will likely see more sea level rise. So I'm going to wrap up here. So why does it matter? One of the questions I often got when I was working on my dissertation is, you just showed me 3.2 millimeters a year. A millimeter isn't much. Well, the reality is a millimeter of sea level rise up equals a lot of shoreline loss. So for example, I was working in the Delaware Bay for my dissertation. In the Delaware Bay, some parts of the bay are losing 3 meters of shoreline a year. Now, the Delaware Bay isn't heavily populated, right? There's not that many people living right next to the bay. And yet we look down to Florida, we look to Louisiana, we look to Texas, we look to other parts of we look to the eastern shore of Maryland, right? And we see that about 40% of the US population is in a coastal area that's vulnerable to sea level rise. So when you see that it's rising at about 3 millimeters a year, don't let that small number fool you into being comfortable, right? That small number actually results in a lot of land loss every year. And we are going to have to grapple with the fact that as we lose land, we lose space to live.
Thank you, Dr. Jaworski. I'm going to start off with a little bit of the local reasons why this is a problem and move on to more global issues. Tangier Island is an island in the middle of the Chesapeake Bay, and it's been experiencing a lot of erosion for a really long time. But because of the way sea level is rising in the East Coast, they have lost about 66% of the island since 1850. And they expect that not much is going to be left in 50 years, and it could be completely gone within 100 years. This is a local community that used to house thousands of people. Now it's only 500 or so people in this island, and it's mostly fishermen that depend on crabbing, but the crabbing industry is having some difficulty as a result of this sea level rise. We're seeing all kinds of problems along the East Coast. In places like Annapolis, we are looking at changing our Naval Academy. In Norfolk, Virginia, we're looking at how to make sure that the Navy base doesn't have any weaknesses or security issues as a result of sea level rise. So they've already spent $250 million to raise the piers, but they expect to have to spend more than twice that just to finish the rest. And this is only anticipating a meter rise. So what if it rises more? Will we be able to be okay with the current changes or have to spend more money on more future changes? Miami is one of the most populous cities in the United States that has become the poster child of sea level rise because they get these king tides, is what they're called, when we're very close to the sun and the moon and the sun are aligned during the full and new moons. We get extremely high tides above the normal highest tides. And you can see that in the picture here. There's a person kayaking in the middle of the roads as a result of one of these king tides. The city has already had to spend upwards to $450 million to raise the city, create pumps, new sewer systems, all kinds of structural changes so that every time there's a king tide, they don't get flooded like this. And it has been shown to work since 2013 when they did this. But the problem is that it's projected to be a problem in another 45 to 50 years. We're going to expect to spend more money. And the picture on the right, you can see the flooding that is projected by 2100, so within the next 100 years. But this is actually the best case scenario. So as Dr. Jaworski said, the most conservative projections are not likely. It's probably going to be worse. So this is what they expect to see if we only see a 2 degrees Celsius global temperature increase. So if we see upwards to 4 degrees Celsius increase, we're going to see more flooding. More Florida is going to be submerged, being that it is a flat, low elevation area and exposed to sea level rise much faster than the northern states. But even with that, New York City, that is in the north, is under a similar issue because New York City is a set of islands. Manhattan is they're already building seawalls and spending billions of dollars to protect the infrastructure that is worth billions of dollars in that city. But globally, what city is the worst city in terms of flooding, that they've had to relocate the capital city of this country due to sea level rise? Well, it's Jakarta. Jakarta has a population of 10 million citizens, but they're expecting that 1.5 million, usually people in the slums, will need to be displaced. They have already purchased land elsewhere 100 miles away to move the capital city. So this is going to be about $33 billion to relocate the capital city. And they have to do this because they're expecting that the city will be completely submerged by 2050, or at least 95% of it will be submerged. This city is particularly at risk, not only because it is a coastal city, but because there's 13 rivers running through it, which erodes land and causes more subsidence and all kinds of issues associated with sea level rise. But it is the city that's sinking the fastest worldwide. Now the Maldives and other Pacific islands are at risk as well. The Maldives, they have a population of about 350,000 in about 250 islands that people live in. They have over 1,000 islands total, but only about 250 islands are inhabited. The picture on the left is of the president signing the Kyoto Protocol underwater as a symbolic gesture of where the country will be if no one did anything about climate change. Thankfully, the Maldives are actually wealthy country. It's a wealthy country, and they've already spent a lot of money purchasing land elsewhere so that they can relocate their immigrants or refugees, if you will. They're purchasing land in Sri Lanka, India, and Australia to move their citizens. Other islands in the Pacific are not as lucky. The Marshall Islands are extremely poor, and they're asking for help. So the World Bank gave them $6 million for adaptation rather than mitigation. So basically that means that they got money to build walls or sand barriers, groins to prevent sand from moving, but they still expect the islands to disappear within the next 50 to 100 years. So what's going to happen to the 50,000 citizens that live on these islands if they don't have money to move elsewhere like the Marshall Islands or the citizens of the Marshall Islands do? Now, Bangladesh is a whole nother case where they've already lost 11% of the land, causing farmers to be displaced. People are moving inland, further and further inland. Some farmers have gone and moved towards aquaculture rather than agriculture, so getting shrimp rather than plants. Others have built rafts out of aquatic plants and straw, and like woven these rafts together to be able to put soil and then plants on top of that floating in the water. Certain crops like onions and pumpkins have thrived, but it's not a very sustainable method of agriculture for a large-scale population. So they're thinking that up to 5 million people will be displaced in the next decade, and over 18 million could be displaced total, about 1/7 of the population. So this is a crisis for places in South Asia and in the Pacific Islands that I've mentioned. In Africa, Africa is also at risk. The sub-Saharan Africa is at risk of sea level rise and other issues associated with climate change. This picture on the left is of a school that was built, a floating school in the slums to deal with the rising sea level. And unfortunately, it did not last very long. This structure fell apart 2 or 3 years after it was built because of a storm that came in and destroyed it. But the city is basically turned into a giant water slum where A lot of people are living right on the water. Their homes are on stilts or floating on the water, or basically living on boats because they're losing so much land so quickly. There are so many other places that are experiencing sea level rise issues. Lots of citizens that we don't know where they're going to go and where they're going to be displaced. So we need to consider that when we look at the United Nations refugee definition of a refugee, which says it has that a refugee is has to have a well-founded fear of persecution because of his or her race, religion, nationality, membership in a particular social group, or political opinion. It does not protect people. It doesn't cover people who are displaced because of environmental catastrophes, weather events, or any other climate-related incident. We have already seen about 65 million refugees or displaced peoples as a result of storms, other weather catastrophes, and flooding. Just in 2018 alone, just 2 years ago, there were 17 million displaced people. And we had over 2,000 in Puerto Rico because of Hurricane Maria that still don't have a home, and then afterwards were, devastated by something unrelated. So we're seeing hundreds of millions of refugees that we could potentially have in the next 3 decades. Where do they go? Where can we place these people? When we're projected to see an increase of applications to the European Union and US for asylum as a result of climate events. And they're projecting an increase of about 28% of these applications by 2100. So some countries are taking refugees, some countries are helping, but they're not taking elderly or disabled peoples that can't work. They are only accepting citizens that can hold a job and can be contributing towards their economy. So it's important to think about this as a human rights issue. Where are these people going to go? What's going to happen next? So that also, like I said, with the weather events, it's not just sea level rise that's an issue. As a result of climate change, we're seeing more frequent and stronger storms. We're seeing droughts in some areas, like the West Coast, which is going to lead to food and water shortages, increased forest fires, and much, much more. Go ahead.
So, what do we do? Well, we can't stick our heads in the sand and pretend it's not happening. I always like to end with this cartoon because it says conclusive proof of stable sea levels. The water still only comes halfway up the duct. So we can't pretend it's not happening. And we see that. We see countries around the world simply trying to pretend that it's not happening. And the reality is that will cause more problems because then we'll have to find solutions in a crisis as opposed to trying to find solutions when we have time. Go ahead. So when we talk about climate change, we talk about the difference between mitigation and adaptation. Mitigation is meant to slow down climate change. Mitigation is meant to address the causes. So mitigation would be things like no longer burning fossil fuels, switching to renewable energy. So mitigation would mainly involve making changes to reduce the number of greenhouse gases we're putting into the atmosphere. Mitigation could also include strategies to remove greenhouse gases from the atmosphere. And while there are efforts in place right now to build things like artificial trees, we're not there yet, right? We are not at the stage of effectively being able to remove greenhouse gases from the atmosphere. So mitigation is trying to lessen the severity. Adaptation is learning to live with the consequences. And so we need to be doing both. We need to be mitigating by reducing the amount of greenhouse gases and thus slowing down the warming, but we also need to be adapting. Because even if we stopped emitting greenhouse gases today, we would still experience some warming and thus some consequences. So when we talk about sea level rise specifically, there's a few different adaptation strategies. And you can see there are 4 of them here. I'm going to focus mainly on protecting and retreating. So protecting, we can engineer shoreline protections. This is putting in seawalls. New York City has a seawall. One of the problems with seawalls is they are very expensive, and they can also cause some unintended consequences. They cause changes in the ecosystems. And the other problem with seawalls is when the water goes on the other side of it, which it will, you have to pump it back out and over. And we saw that in New York City after Hurricane Sandy, where the storm went over the seawall, and then the city was flooded, and they had to bring in all these pumps to pump it back out, which was expensive and time-consuming. So seawalls and other engineered structures are options. And then actually I will mention accommodation. The accommodation would be putting houses up on stilts. One of the things we saw after Hurricane Sandy in New Jersey is that a lot of houses in New Jersey after Sandy were actually put up on stilts to allow the water to come in and go under the house. Okay? There's also natural protections. And natural protections is things like replacing forests, replacing coastal wetlands. Coastal wetlands are like giant sponges, and they actually help to reduce storm damage. They help to absorb floodwaters. The Chesapeake Bay, right here in Baltimore, the Chesapeake Bay Foundation and the Chesapeake Bay Program both are pushing heavily to protect our shorelines naturally. While this won't prevent all the flooding, protecting shorelines naturally tends to be less expensive, tends to have less unintended consequences, and it does work. Okay, it's not perfect, but it does work. And then finally, we have retreat. And the reality is, in some areas, we will simply have to retreat. But that will be a tragedy, because that will be the loss of communities, right? How can we tell people, right here in the US, right? Your families have lived in these places for generations. How do we tell them they have to leave? And where do they go, right? And that's going to be a struggle right here in the US, right? Whole cities of people are going to be displaced. And then we think about the global implications of this. Whole countries are going to be displaced. Where do they go? Okay? So retreat is going to have to be one of the strategies, but it will be a devastating one. Just mitigation examples. On the left-hand side is examples of energy generation that do not produce fossil fuels. The top picture is nuclear energy, and we know that nuclear power does have some consequences, but it does not produce any greenhouse gases. On the right are some examples of other ways of mitigation, and this is what I mentioned with those artificial trees, things like underground carbon storage. There's even been discussions of putting mirrors up to reflect the solar energy away. None of these strategies are ready to be used. None of them, we don't know if any of them will be effective. And of course, we have to be careful with all these strategies for unintended consequences. For example, whenever I show this slide to my aviation students, their first thought is, won't those mirrors blind planes? And I'm like, we would have to be careful with that, okay? So just examples of mitigation strategies.
So not only can we mitigate to reduce some of this consequences that we've already talked about, but each of us can do something. Small actions do go a long way, especially if everyone's doing these small actions. And not only that, you can save money in your electric bill or water bill, for example. Using cold water instead of warm water to wash your clothes, that's an example of an energy saving, energy saving technique at home. Hanging your clothes rather than drying them. There's all kinds of examples here, like buying rechargeable batteries rather than buying regular batteries, because if you reuse something, it cuts down on the energy of making that product. So if you buy batteries constantly, you're using energy not only in the battery itself, but in the energy that was in the cradle to grave process of that product, that energy that went into making that battery. Using energy efficient light bulbs, using anything that reduces your heating or cooling in your home, which is a big energy consumer in your home, is your AC HVAC system. So if you put on a sweater during winter and lower your heating, use fans rather than air conditioning when it's warm. There's all kinds of small actions that go a long way and save you money down the line. Another important small action that each of us can do is eating local. You always hear about the cutting down of meat. If you eat beef, you are producing a lot of methane in the way that cattle was raised. If you're eating cattle that was raised in a CAFO rather than a local Amish farm, for example. But even just eating local, like eating something that was produced within the tri-state area rather than something that was produced in California or Africa or South America, cuts down on a lot of energy consumption. So there's this interesting statistic here that is, if every US citizen ate just one meal a week that was local and organic, for example, or locally organic raised meats, grains, or produce, we would reduce the amount of oil we use every week by 1.1 million barrels, which is a lot. So not only is it better for the environment to eat local, it's better for the local economy because you're putting the money back into our economy, and it's better for your health because you can control what goes into your food a little bit better. There's a lot of studies that show that cheaply made foods far away in massive CAFOs are full of pesticides and full of a lot of toxins. So it's healthier to eat local, it's better for the economy, and it saves on greenhouse gases, reduces greenhouse gas emissions overall. Then it's also better for us in terms of health. So there's some controversial statistics out there, but in cities like New Delhi and Beijing, where there's a lot of energy produced through coal power plants, there's what we call the dirty six pollutants, that are air pollutants that cause harm to human health. There's so much of those dirty six pollutants in those particular cities that they equate breathing the air in those cities to smoking up to 45 cigarettes a day. So we saw actually with the coronavirus shutdowns and people being isolated at home, that places like New Delhi have no smog right now. There's no ozone, tropospheric ozone right now causing asthma because there's less pollution out there. We're producing less energy. We're cutting down on these pollutants. So by cutting down on energy use, we're reducing the air pollution that causes harm to human health. And here are some, in this picture, some examples of different organs or human parts that are affected by air pollution. So there's statistically 7 million people die every year worldwide because of air pollution. So we could cut down on this simply by cutting down on our energy use. And you can see on this graph on the left that most of our air pollution is coming from electricity generation. So again, those small acts that I mentioned before play a role in cutting down on this toxic air pollution. Now there's some slightly larger acts that require a little bit of investment. If you purchase a home, it takes about 20 years for it to be worthwhile to buy solar panels, but nowadays you can lease them or even get incentives by companies who have these solar panels. There's also electric cars or electric plugins. For example, I have an electric plug-in. It is a car that runs on gas, but also has the possibility to run on electricity. So if I charge the car, I cut down on 30 miles of driving each time. That would be used, that would be oil. I'm using electricity instead. And if I have new renewable power, like we do at CCBC or at my home, then it's cutting down on those greenhouse gas emissions. Some of the newer electric cars can run up to several hundred miles without needing a charge. So they're becoming more and more feasible, and more infrastructure is being built to charge these cars. Of course, it does require a little bit more of money and initial investment, but in the end, it ends up paying off when you don't pay for gas, for example. So overall, the biggest thing that we can do is, vote, not only vote for or the people who are going to incentivize lowering greenhouse gases or enforce some of these large scale changes, but also vote through the way you purchase goods. Simply buying products that have lower packaging, buying products that are more efficient, energy efficient. You're making a choice that is affecting the economy, and it's voting through purchasing of items. So it is important to contact your representatives and encourage them to invest in, reducing greenhouse gas emission mitigating laws, and support research so that we know what's going to happen in our state, in our country, in the world, and so that we can protect ourselves and are better prepared in the future. So this is a very complicated science, as you may have gathered. We have a lot of information that we have given, and there is a lot more that can be said about this, or we can clarify misconceptions or questions, concerns that you may have. Of course, we don't have a face-to-face panel now, so you can contact any of the three of us, but I have provided my email here, so you can send me questions if you are interested to learn more about this or about any other ideas or concepts that are related to climate change and climate refugees. So I hope that you enjoyed this lecture, and have a good day. Stay safe, stay healthy.